All right, I wanted to take this opportunity to go over the simulator that we're going to be working with. There's a few things. What we're trying to do is simulate as if we have a conveyor, which we don't have. So I'm using some proximity switches and some relays that we're going to interface with the PLC. With proximity switches, they come in two different varieties. Well, they actually come in many varieties, but there's two different wiring formats and schemes. These are what they call inductive or proximity switches that require a metallic object or something for it to generate eddy currents that cancels out or triggers a switch. You also have capacitive, etc. But the big thing here is that when I purchased these, I purchased these without paying too much attention and discovered their NPN. NPN is from the transistors, basically. You have the negative, positive, negative, and this means that the outputted signal on these is negative. And when we're doing and working with the PLC that we're working with, there is the possibility that you can have syncing and sourcing inputs. It requires different wiring, which none of our trainers are designed for. We're designed for strictly syncing our inputs. So these little rascals would not do the job because they're backwards. The PNP puts out a positive signal, and the input terminals are designed to look for a positive signal to say that something is on. These put out a negative signal, NPN, so they won't work for us. But what we've done is I've installed a couple of intermediary relays. Now, there's different terms used for these relays. Some call them intermediary, some of them call them interposing. Basically, they are a way of using the different forms of input that may be of a different voltage or a different source than the PLC can look at. For example, when you do motor control, you may be signaling a 24, and if the coil voltage on the motor control relay is 24 volts, then there's no problem. The coil and the wiring contacts are electrically isolated, which means that if you apply voltage to the coil, it's not going to be livening up the contacts that we're examining. This means that another device can monitor the contacts and we control the coil. In this case, we're using these proximity switches through a little power supply, and the power supply is giving us 24 volts, and that's what's livening this up. As I slide this, you can hear and you can actually observe the relay changing state, and then the other one's changing state. And we're going to use those as part of our logic and connect them up. But I thought this would be a really good opportunity to take a minute or two and kind of go over relays themselves. So I've got one of these relays and just to kind of show you the parts, so when you're watching it actually work. All of the magic is taking place because of this little armature and this coil. So these two contacts are going to put 24 volts across that. Whenever that happens, whenever there's something that causes there to be 24 volts there, this little coil generates a magnetic field, and the magnetic field then, it's kind of hard to see, but there's a little slug right there on the top. And that actually is a bar that runs through all that coil, and it creates a very strong magnetic field which goes out, and then it attracts this metal bar, which is actually an armature. So when it moves, as I'm going to show this for a second here, when it moves, it actually is changing the state. It's actually moving this armature. Attached to this armature, this a little closer, you can see that there are plastic with little brass or copper reeds on it. So when this changes state, the contacts here, right now they're normally closed, there's no power. When I apply power, make it change state, this will drop down, closing that. So I'll then have power to that contact. So this is normally open because it's a shelf state. These are normally closed. If I can zoom in a little bit closer without losing. So this is why we say when you energize the coil, the normally closed contacts open and the normally open contacts close. And we use this because these two contacts that are looking and examining the state of these two contacts, these are electrically isolated. You can see there's insulation there, there's insulation here, there's got no relevant to this other than the magnetic field. So what that allows us to do is to have another device monitor that. In our case, on this particular board, we're doing exactly that. These are the controls, the wiring positions that are being controlled by the proximity switch. So our 24 volt comes in, and proximity switches have a fairly standard wiring scheme. Normally the brown is the power, and the blue is the negative return, and the black is the actual tripped switch signal. So the 24 volts is coming in, and as I trip this, it's energizing one or two of these coils. So this one's energizing this coil, and this one's energizing this coil. On the top here, we have these terminals, and what they do, they are fed to this terminal block, which is our PLC input terminals. So I have to have a common because we're going to send 24 volts out, and that goes and is tied across the two of them at the same terminal screws relative on each relay. And then the output of the relay, which is actually feeding that power through, then goes back and is detected by the PLC, and we can use it in our logic. So these are, I'm calling these the NPN proximity switch intermediary relays because they're doing the intermediary work. This is our PLC connections. This is our 24 volt, which is kind of overkill. And these are our two proximity switches. This is a simulation as if we've loaded a parcel. We move it along, get to the end, we should release our latch.